Hello, everyone. Today, we will learn Section 2 of Chapter 7, Core Concepts and Principles of Ethereum. In Ethereum, the global shared state is made up of state accounts. These accounts interact with each other through a messaging architecture. Each account has an associated state and a 20-byte address. Ethereum's account structure consists of several components, including nonce, account balance, code hash, and storage root node. Of course, Ethereum accounts can be divided into two types. One type is the externally owned account, EOA, which is controlled by a private key and is not associated with any code. The other type is the contract account, which is controlled by contract code and is associated with code. So, let's first analyze externally owned accounts, EOA. These accounts store the state of the balance of Ether and have a pair of public and private keys. Its feature is that it holds a certain balance of Ether and can send transactions. The address is generated from the public key, controlled by the private key, and does not have any associated code. An EOA can conduct transaction by creating and using its private key and can give a sign to the transaction. Messages sent between two EOAs are simply value transfers. Messages from an EOA to a contract account will activate the contract's code, allowing it to perform various actions, such as transferring tokens, writing to internal storage, mining new tokens, and executing certain computations or creating new contracts. A contract account, however, is an account containing contract code. It is not controlled by a private key, but by contract code. Its features include having a certain balance of Ether and associated contract code. The address is calculated based on the address of the contract creator and the number of transactions sent from that address. The execution of contract code is triggered by transactions or other contract messages. Contract code can perform Turing-complete operations and can read and write to its own persistent storage, but it cannot access the storage of other accounts. It's important to note that a contract account cannot initiate a transaction by itself. It can only execute after receiving a transaction. For example, a transaction initiated by an externally owned account or another contract account in response to a transaction. Finally, let's compare externally owned accounts and contract accounts. Both types must have a balance of Ether, meaning your Ether balance cannot be zero. Regarding the content being transferred, an EOA mainly transfers transactions, while a contract account transfers transactions or messages. The EOA is controlled by the private key, while the contract account is controlled by the contract code. Let's look at the Ethereum Virtual Machine, EVM. The Ethereum Virtual Machine is the execution environment for smart contracts in Ethereum. It can execute any complex algorithms, and it operates as a completely isolated sandbox. Its internal running code cannot interact with the network, file system, or other processes. Smart contracts can invoke each other. Every Ethereum node runs the Ethereum Virtual Machine to ensure consistency across the entire blockchain. The difference between EVM and other Turing-complete machines is that its total amount of computation that can be performed is controlled by the amount of gas provided. Let's look at this concept, gas. Gas was introduced to address two issues. First, the smart contracts in the Ethereum network are executed repeatedly on all nodes, consuming a lot of computational resources. Second, malicious actions from attackers or improper operations by developers could cause the EVM in Ethereum nodes to run contract code in an infinite loop, leading to system crashes. Therefore, for limiting the workload of Ethereum node operations, preventing abuse of computational resources and inspiring the nodes that participate in computation by paying operation fees. Gas was introduced. In other words, when a transaction or message triggers a contract code in the EVM, it will specify the gas consumed by every operation step. Let's look at the differences between gas and Ether. Gas exists within the EVM, while Ether exists within Ethereum accounts. Gas is used to measure the cost of executing each operation step. Of course, the unit of gas corresponds to the computational units that have natural costs, while the price of Ether typically fluctuates based on market supply and demand. Okay, everyone, we have now completed this section. Meanwhile, this chapter also have been completed. Through this chapter, we must focus on understanding the development of Ethereum, grasping its design philosophy, mastering Ethereum's core concepts and principles, familiarizing ourselves with Ethereum wallet clients, browsers, and understanding distributed applications. Okay, this chapter ends here. Thank you.